Hello. So in this lab, we'll be getting familiar with the Amazon Elastic MapReduce. So what is Elastic MapReduce? So in simple words, if we say Elastic MapReduce help us process huge amount of data, that is variety of application, and perform various tasks such as log analysis, web indexing, data warehousing, machine learning, and financial analysis. Means all type of work. It will distribute them into various processing servers. Means all this task cannot be performed by a single server or single computer. This task is divided into several set of computer that are present in a map kind of form. So but if we look into the definition of elastic MapReduce, it is easy to process amount of data in variety of application including log analysis, web indexing, warehousing, financial analysis, simulation, this, and it help and produce resizability cluster for Amazon EC2 instances. Means it will distribute our work and raw data and processing into computers. Means our data and our processing power will be distributed among many computers. It will not be performed by a single computer. Means task will be distributed among various set of computers. So in this lab, we will use Elastic MapReduce provided by Amazon to distribute our work among various servers present in a map. So it is also mentioned here that it is distributed processing architecture MapReduce, which in which task is mapped into several set of server for processing, and computation by those server is then reduced into a single output set. So this definition is somewhat difficult if we look at the diagram. So here we can see that there are various computers present, various servers. This means various set of computer. There may be Linux, Windows, Apple, iOS, means various kind of computers are present in this map, and this all set of computer or servers are present in a map, and this map is reduced to a single set of computer, and job performed by single set of this computer, job performed by this computer is reduced into this map. Means all this computer processing power, it is reduced into a single computer. That's why it is called a map reduce. That is, we are reducing set of map into a single computer. That is, a map consisting of various server, various processing power is reduced into a single computer, which has that much power and efficiency, and with no latency it will perform the huge amount of work and huge amount of processing that is performed by a single that is performed by a various set of computer. That much processing is can be done with this computer with the help of elastic map reduce. So in this if we look into the definition now, so Amazon Elastic is managed cluster platform that simplify running big data frameworks such as Apache. This is and analyze vast amount of data. Now the elastic in this refer to dynamic resize ability, which enable administrator to increase reduce resources depending on current need. Now this map can be reduced or increased. Means I can increase the size of this map or reduce the size of this map according to my needs and according to my requirement. That is very much important, that whenever I need to increase the size of map and increase the processing power of my computer, then I can reduce or decrease the size of this map. That's why the word elastic is mentioned here. So now we have getting familiar with what is elastic map reduce. Elastic is, that is, we can elastically adjust the size of this map, and map reduces, we have reduced the processing power of various set of computer into a single computer. Now we come to our main objective of this lab, that what we will be doing in this lab. So here first we will be there are two types of work we will be doing using this parallel set of, means distributed set of processing. That first we will be analyzing various set of computer that are performing this job. That is, various set of computer present in this map, we will be performing task to get information related to various set of computer present in this map that are performing our job. That is, there may be 14 Linux server present here that is doing my job, 16 Windows server that is performing my job, 20 iOS server that is performing my job. So I will get information regarding all the servers or all the computer that are present in this map that are performing my job. So I get some idea that this much of Linux server is doing, this much of Windows server is present, this much of iOS server is present. So first we will be running script and analyze our CloudFront logs to CloudFront logs to get information about the operating system and how many of such operating system means ki Linux operating system, then how many server of Linux operating system are present. And our second work is word splitter. That is, there is a Microsoft Word for example, there is a Microsoft Word file present where several content is present, like this file we can also take that this much content is present. Now we can split the words of this content, means if there is a content like the brown fox jump, now we want to print each word of this line below into a separate line, then we can use the word splitter. The brown and fox means each word of this file will be printed in a new line. Or in the advanced options, we can use the word splitter to analyze the resume to get some word and how many word is repeated how many times. So for this kind of purpose we will use word splitter. So for that we'll be using Python script. So these are the two work that we are performing in this lab. First one is to get information regarding the operating system running, and second one is to get information to get a program of word splitter to get information regarding how many type of particular word are present. So so for that, first we will be creating an EMR cluster that will be seeing at the top menu, first EMR cluster. And for that we have to create a bucket where we will be providing the input, that is what our program will be, that input will be provided and go to EMR cluster, and that job will be performed. And when job will be completed, that output will be provided by the EMR cluster and stored in the output folder. So first we will create a bucket, and there we will create two folder, input and output. And then we have to create a extra folder logs, where logs will be stored, that what type of work is performed, that log will be stored related to that cluster. So here important thing is to mention, here we will be creating a step. Now what is step? Step is a unit of work we submit to a cluster, means every work we have to submit to a cluster, means every job we have to submit assign to a cluster, we will be assigning it through the step. Means we will create a step, and there we will provide the input path and output part, means where our work will be getting, means from where our job will get input and where our job has to store output. That path will be, that is input and output path will be provided in the job process, but logs path will be provided while we will creating the cluster, because cluster will generate log related to the every event. So we will be seeing it later also. But if dot understand, then let's go to the lab steps. So our first step is to create a s3 bucket. So here we can see that we have created a bucket, and there we created the output logs folder, and that's which will be our first step. And now our second step is to create an EMR cluster. Now there are two modes present in a cluster, that is there are two modes to create a cluster, that is cluster launch mode and step execution mode. In cluster launch mode, cluster will not automatically terminate, means we have to explicitly click on the terminate button, then only cluster will terminate. While in the step execution mode, cluster will automatically terminate after step process expired. Means step, what is step? Step is a unit of work that we have mentioned earlier. So after the our job will be completed, the cluster will terminate automatically in step execution mode. So here we can also see that there are two mode present in the cluster, that is cluster launch mode and step execution mode. In cluster launch mode, it will not automatically terminate, while in step execution mode it will terminate automatically. Now also there are three types of node present in the cluster. The one is the master node. It is the one, and it is present one in every cluster, and it is must for every cluster, and it manages the cluster and all software component needed to distribute both data and tasks to a slave node. Now slave node perform the task, so it will, means it is the head of the cluster and manage all the resources and software component, that means all the work that will be assigned to the nodes and all the data where I have to distribute this work, and that means it is a head of the a particular job architecture, and it will distribute the work to the other nodes. And core node, there are two difference between there are two other node, which is core node and task node. These are slave node. Slave node means they will perform the task. Now the core node, it will take care of the it will include software and run task. It means it will do processing job and also store data, while the task mode, it will only do processing. Means it will only run task and not store data. It is clearly mentioned from the name itself that task, it will only execute task, and core will take care of everything. Means it will run task as well as store data. Now we will create our first cluster. Now we get some basic understanding what is master, core, task, and what is cluster launch mode, step, execution mode. Now we'll be creating our first cluster to get information regarding the operating system present. So first we will be creating cluster, not assigning any work. So that will we will be doing in the next step. First we will be creating a cluster only. So for create cluster we will go to EMR and click on create cluster. So there will be two option present, quick option if we have to go with the basic configuration, and can go to advanced option. So there is this thing we can select upon our requirement, that what type of instance type, number of instances. Here we have chosen two, one for master node and one for slave node. We have not gone for other nodes. So if we want more processing power or more speed and less latency, then we can increase our number of instances and etc etc. And there we can also see various configurations, general configuration, software, hardware, and security configuration. And then we will create it the our cluster. So our cluster is created, but job is not assigned yet. So now our first job is, as we have mentioned, we have to look into the operating system logs and analyze how many type of particular operating system computers are present in our map. That is, if we look into the map, how many of Linux server are present, how many of Windows, how many of iOS. So now we can also see here that we will run a Hive script that process Amazon CloudFront log files. As Amazon, what is CloudFront log files? As CloudFront is cost effective way to distribute content with the less latency and high data transfer speed. So it is web service. So we web service that provide us cost effective way to distribute content. So we can analyze how many data is distributed among how many server, that how many is gone through Linux server, how many is gone through Windows server. So this group looked at the CloudFront log, identify the different operating system that make requests through CloudFront, and tabulate how many for each operating system, and how many Windows operating system, how many Linux operating system, this and that. Then to assign a task, we will go to the cluster and click on step. Here we can see the step and click on add step, and here we will mention Hive program. And here we will mention, as I have said it earlier, that here I have mentioned the script S3 location and input location from where it will be getting input, that is script input, and output location. For this lab purpose they have provided us input location, means all the code present in the input will be provided by them. So input location we will mention, and output S3 location we will mention the bucket location we have created in the first step. And then click on add, and then we will see that this bucket is running. Now we have assigned the job to our cluster, means our cluster is performing the job. Now we will see the output of this. There are various ways to view the EMR result. Means we can view the EMR result through maps and other ways also, means through console also, and view the result in the log files. So here first we will be seeing we will seeing the monitor section to analyze our result, that how many job is completed by our cluster, that we can see in the monitoring session. Here we can see apps submitted, apps running, and apps killed, app failed. Means all this we can see in the monitoring section by going into our cluster. Means here when we click on our cluster, there we can see monitoring section, and here we can see all the maps and other things present. And when we go to our go to our steps section, there we can see view logs menu. So here we can get information regarding how many operating system are run. So if we go to the console view, so we will go to the S3 bucket location and output folder, and their operating system request there. In the operating system request file, all the operating system request will be stored like in this format. Android means Android type of version. There are 855 server present, Linux 813, Mac OS 852, OS X 799, and Windows Server 883, and iOS Server 799. Means in the map how many type of each operating system is present, that is this Windows, this Linux. So this all will be stored in the S3 bucket, as we have mentioned the output folder while creating the cluster, while creating the step, not cluster. We will not assign the output location while creating cluster. We will specify output location by creating step. That is when we are creating a job, then we have to mention where we have to store the result. So while creating the job, we have mentioned that it will store the content in the S3 bucket output folder. So it has stored the request. So our first job is completed. That is, we have get the information regarding various or different operating system that make request, and tabulate how many for each operating system, means how many of each operating system are present in this. And this is also mentioned here that we have analyzed that. Now we will go to our second step. Now, in basic way, we can perform the second job by simply clicking on add job, or deleting a cluster, deleting this cluster and creating a new cluster. But for this purpose, we will terminate this cluster. Means, if we will come to this, we will terminate this first cluster, upper cluster, which is performing the log analysis job of the operating system. We will terminate this cluster and create a clone of this cluster. What is clone? Clone is simply a copy of this cluster, and specify which entries you have to copy, and create a clone of this cluster. And then using this, we will be analyzing our uh, will be performing our second objective, that is to perform a word splitter job. So for that, we have terminated our cluster by clicking on this, and that cluster will be terminated. It will ask if we have to include the step, means if we have to include the previous job that we have done. So we'll click on no, and then we will clone our cluster, and our cluster will be cloned. Here they have mentioned that there are option also present while cloning a cluster, that we have to clone a cluster in step execution mode, or simple mode, cluster launch mode, so that we can take care of according to our needs. Means according to our understanding that what type of cloning we need. Then coming to our last objective, that is to perform a word splitter program, which is our second job, using the cloning cluster that we have performed. So that Python script is provided here. If we briefly go to the Python script, it will, for every line in the system, means for every line in the word, it will look for the pattern. It will look for the all the pattern which is consisting of A to Z, means all the words in that line, and print that word in lower value, and append a one tab, and at the end one. So for example, if there is a line, the lazy brown fox jumped over the moon, it will print the one lazy one, as we have appended word lower, then we have appended one. So that's why it is printing one every time. So for that, they have provided us the create cluster text file, and then we will upload this text file into the input S3 bucket. In the previous work, the input is provided by them, so we have not uploaded an input in the S3 bucket, but here we the input is provided by them, so we downloaded it and provided it in the input bucket. And then we go to the step, and similarly create a step and provided the input location and output location that we have mentioned earlier. And then when we here we have provided the output location previous one, means the output folder we generated previously, that location we have provided. We have not created any new folder for output location. But when we create on add step, then after some time we will get an error of failed. So why we get this error of failed? It is because the it is because the so we get this error because the output folder we have mentioned, the location of the output folder we created earlier. We have not specified any new location for the output folder. That's why it is giving error. So it is also mentioned here. The end of syslog is very helpful for the streaming application. Here we will be adding a job of streaming application. In the previous one, we will have a program of Hive application. Here we will be getting a streaming application, means it will stream the content. Whereas in the Hive script, it will execute the task. So here for streaming application, the designated folder S3 can't already exist. Means the folder has to be a new one, which will be which will be created by this task. It will not be the previous folder. So we will delete the folder by going to the S3. So we will go to the S3 and click on delete the output folder. Now there is no output folder present in S3. Now we again clone the step, means again execute the same stack, means create a copy of the above step, and click on add step. Then after some time it will go to the running state, and our program will be running, and we can analyze our result. Here we can also look at the logs after some time by going to the same view logs. And there we can when we go to the console and go to the output folder, there we can see the folder containing part 00, means it will distribute the all the content of the word file in the form of parts, so we can analyze some simple parts. So when we click on some part hashtag, means some part 01 02 03, means it will generate various files for assigning for distributing our work. So if we click on any one part file, then we can see the result that our word splitter has done its job, that it split the word it split the content of the word file, that is accept, add, and also giving the frequency of each word, that is accept is occurred one time, and occur 31 times. So that's all for the purpose of lab. So in this lab, we analyze what is elastic map reduce and how it reduce the power of various operating system and server into a single computer. That is, it is reducing the map into a single computer, and it is elastic, that we can adjust this adjust the requirement, that is speed, efficiency, and other processing speed and resources we need according to our needs. And then we also see various modes in which we can run cluster, and three types of node present: master and master's task or core node. Master node is simple one, which administrate and distribute the work, and the other one is core node, which perform the task as well as store the data, and the task node only perform the task, does not store the data. And then we we perform two cluster. So first cluster for analyzing the logs and identify different operating system that make request, and second one for the word splitter. So for this purpose we will clone cluster, and then when we edit step, then the step does not execute successfully as the output folder is already previously created. Then we clone the step and then perform the work, then word splitter has done successfully. So that's all for this lab, and thank you.